The necessity for electric water coolers, or UCs, in commercial buildings to be connected to a ground fault circuit interrupter, or GFCI, outlet or circuit breaker hinges on several key factors. Firstly, building codes play a crucial role. Local building codes often stipulate specific requirements for GFCI protection for EWC. Consulting the local building code is paramount to ascertain the exact mandates applicable in a particular jurisdiction. Secondly, the American National Standards Institute, or ANSI, and National Science Foundation, or NSF, Standard 61 for drinking water system components mandates that EWC installed within the food service industry must have GFCI protection. Thirdly, underwriters' laboratories, or all, listing is another determining factor. EWC that have been UL listed for use in commercial settings might incorporate a GFCI protection requirement as part of their listing. Considering the information available, it is generally recommended to install EWC with a GFCI outlet or circuit breaker. Firstly, safety is a primary concern. GFCIs offer a protective measure against electrical shock hazards by promptly detecting ground faults and interrupting the circuit. This is particularly crucial for equipment like EWC that involve water. Secondly, code compliance is essential. Many localities have adopted building codes that mandate GFCI protection for EWC, so ensuring adherence to these codes is vital. Thirdly, manufacturers' instructions should always be considered. Certain EWC manufacturers might specify GFCI protection as a requirement in their installation guidelines. There might be exceptions to the GFCI requirement for EWC. Firstly, hardwired EWC which are permanently connected to the electrical system may not require a GFCI outlet. Secondly, EWC positioned in dedicated areas or equipment rooms where the likelihood of water spillage is minimal might not necessitate GFCI protection. As a general guideline, it is a best practice to install EWC using a GFCI outlet or circuit breaker, unless a specific exception applies. This approach ensures safety, compliance with codes, and adherence to manufacturer recommendations. If uncertainties or concerns arise, consulting with a certified electrician or the local building official for expert guidance is always advisable. A ground fault circuit interrupter, or GFCI, is a safety device designed to protect individuals from electrical shock. It works by monitoring the balance of electrical current flowing through a circuit. In a normal electrical circuit, the current flowing to an appliance or device should be equal to the current returning from it. A GFCI constantly monitors this balance. If a ground fault occurs, meaning that some of the current is leaking to ground, the GFCI detects this imbalance immediately. Even a small difference in current, as little as 0.5 amps or 5 milliamperes, can trigger the GFCI. When a ground fault is detected, the GFCI quickly interrupts the circuit, cutting off the flow of electricity. This interruption happens very rapidly, typically in a fraction of a second, fast enough to prevent a dangerous electrical shock. GFCIs are commonly used in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, garages, and outdoor locations. They are often installed in outlets and circuit breakers to provide protection for the entire circuit. By quickly detecting and interrupting ground faults, GFCIs significantly reduce the risk of electrical shock injuries and save lives. Understanding the National Electrical Code, or NEC, and local building codes is crucial when determining GFCI requirements for electric water coolers. The NEC provides a comprehensive set of standards for electrical installations, but local jurisdictions often adopt and modify these standards to suit their specific needs and priorities. Therefore, it is essential to consult both the NEC and the local building codes to ensure compliance. Firstly, the NEC addresses GFCI protection in various sections, specifying locations and equipment where GFCI protection is required. These requirements are based on the potential for electrical hazards, such as wet or damp environments. Secondly, local building codes may have additional or more stringent requirements than the NEC. For example, a local code might require GFCI protection for all outlets in a commercial kitchen, even if the NEC does not specifically mandate it. Thirdly, it is important to stay updated on the latest versions of both the NEC and local building codes. Electrical codes are regularly revised to incorporate new technologies, address emerging safety concerns, and improve installation practices. Consulting with a qualified electrician or electrical inspector is highly recommended to ensure that all electrical installations meet the applicable codes and standards. They can provide expert guidance on GFCI requirements, proper installation techniques, and any local variations in the code. Failing to comply with electrical codes can result in fines, penalties, and potential safety hazards. Therefore, it is essential to prioritize code compliance and seek professional assistance when needed. Electric water coolers in commercial buildings are commonly used in various locations, including office spaces, schools, hospitals, and public areas. These coolers provide a convenient source of drinking water for employees, students, patients, and visitors. However, due to their proximity to water and potential for electrical hazards, it is important to understand the specific GFCI requirements for these appliances. Firstly, in office spaces, electric water coolers are often located in break rooms, kitchens, or common areas where employees can easily access them. GFCI protection is typically required for outlets in these areas, especially if they are near sinks or other water sources. Secondly, in schools, electric water coolers are commonly found in hallways, cafeterias, and gymnasiums. GFCI protection is essential in these locations to protect students and staff from electrical shock hazards. Thirdly, in hospitals, electric water coolers are often placed in patient rooms, waiting areas, and staff lounges. GFCI protection is crucial in these settings to ensure the safety of patients, visitors, and healthcare professionals. Fourthly, in public areas, such as parks, libraries, and community centers, electric water coolers may be installed to provide drinking water to the public. GFCI protection is necessary in these locations to prevent electrical accidents and ensure the safety of the community. Regardless of the specific location, it is important to assess the potential for water exposure and electrical hazards when determining GFCI requirements for electric water coolers. Consulting with a qualified electrician and reviewing the applicable electrical codes and standards is essential to ensure compliance and protect the safety of building occupants. ANSI, or American National Standards Institute, and NSF, or National Sanitation Foundation, Standard 61 plays a significant role in ensuring the safety of drinking water systems and components. This standard establishes requirements for materials and products that come into contact with drinking water, aiming to prevent the contamination of water with harmful substances. Firstly, ANSI/NSF 61 covers a wide range of products, including pipes, fittings, valves, storage tanks, and water treatment chemicals. It sets limits on the amount of contaminants that can leach from these products into drinking water. Secondly, the standard requires that products undergo rigorous testing to ensure that they meet the established safety criteria. This testing involves exposing the products to simulated drinking water conditions and analyzing the water for any contaminants that may have leached from the materials. Thirdly, ANSI/NSF 61 is widely recognized and accepted by regulatory agencies and water utilities across the United States and internationally. Compliance with this standard is often required for products to be used in drinking water systems. Fourthly, for electric water coolers, ANSI/NSF 61 is particularly important because these appliances come into direct contact with drinking water. The standard helps ensure that the materials used in the construction of water coolers do not introduce harmful contaminants into the water supply. Fifthly, in addition to material requirements, ANSI/NSF 61 also addresses the design and construction of drinking water system components. It specifies requirements for preventing cross-contamination, ensuring proper drainage, and facilitating cleaning and maintenance. When selecting electric water coolers for commercial buildings, it is essential to choose products that are certified to ANSI/NSF 61. This certification indicates that the products have been tested and meet the established safety standards for drinking water system components. Always look for the ANSI/NSF 61 mark on the product or packaging to verify compliance. UL, or Underwriters Laboratories, listing is a widely recognized and respected certification mark that indicates a product has been tested and meets certain safety standards. UL is an independent, non-profit organization that has been testing products for safety for over a century. Firstly, UL listing covers a wide range of products, including electrical appliances, electronic devices, and building materials. The UL mark on a product signifies that it has undergone rigorous testing to ensure that it meets established safety requirements. Secondly, the testing process involves evaluating the product's design, construction, and performance under various conditions. UL engineers assess the product's ability to withstand electrical stress, mechanical stress, and environmental factors. Thirdly, for electric water coolers, UL listing is particularly important because these appliances involve both electricity and water. The UL mark indicates that a water cooler has been tested to ensure that it does not pose a risk of electrical shock or fire. Fourthly, UL listing also includes periodic inspections of the manufacturing facility to ensure that the product continues to be produced in accordance with the safety standards. This ongoing surveillance helps maintain the quality and safety of UL-listed products. Fifthly, when selecting electric water coolers for commercial buildings, it is essential to choose products that are UL listed. This certification provides assurance that the product has been thoroughly tested and meets established safety standards. Sixthly, the UL mark on a water cooler typically includes a control number that can be used to verify the product's listing on the UL website. This allows consumers and inspectors to confirm the authenticity of the UL mark. In addition to UL listing, other safety certifications may also be relevant for electric water coolers, such as CSA, or Canadian Standards Association certification, and ETL, or Electrical Testing Laboratories, listing. These certifications provide similar assurance of product safety and compliance with established standards. Always look for recognized safety certifications when selecting electric water coolers to ensure the safety of building occupants and compliance with applicable codes and regulations. When installing electric water coolers, or UCs, on a ground fault circuit interrupter, or GFCI outlet or circuit breaker, there are several important steps to follow to ensure a safe and code-compliant installation. Firstly, before beginning any electrical work, always turn off the power to the circuit at the circuit breaker panel. This will prevent electrical shock and ensure your safety. Secondly, identify the appropriate GFCI outlet or circuit breaker for the EWC. The GFCI should be rated for the voltage and amperage requirements of the water cooler. Consult the water cooler's nameplate or manufacturer's instructions for this information. Thirdly, if installing a GFCI outlet, carefully remove the existing outlet from the electrical box. Disconnect the wires from the old outlet and connect them to the new GFCI outlet following the manufacturer's instructions. Be sure to connect the wires to the correct terminals and tighten the screws securely. Fourthly, if installing a GFCI circuit breaker, remove the old circuit breaker from the panel and install the new GFCI circuit breaker in its place. Connect the wires to the GFCI circuit breaker according to the manufacturer's instructions. Fifthly, after installing the GFCI outlet or circuit breaker, test it to ensure that it is working properly. Most GFCIs have a test button that you can press to simulate a ground fault. When you press the test button, the GFCI should trip, cutting off the power to the circuit. Sixthly, if the GFCI does not trip when you press the test button, or if you have any other concerns about the installation, consult with a qualified electrician. They can help you troubleshoot the problem and ensure that the installation is safe and code compliant. Seventhly, when connecting the EWC to the GFCI outlet, use a properly sized and grounded electrical cord. Do not use extension cords or adapters, as these can create a safety hazard. Eighthly, ensure that the EWC is properly grounded according to the manufacturer's instructions. This will help prevent electrical shock in the event of a ground fault. Ninthly, after the installation is complete, label the GFCI outlet or circuit breaker to indicate that it protects the EWC. This will help prevent accidental tripping of the GFCI in the future. By following these steps, you can ensure that your EWC is safely and properly installed on a GFCI outlet or circuit breaker. This will protect building occupants from electrical shock and help you comply with applicable codes and regulations. Hardwired electric water coolers, or UCs, are those that are permanently connected to the building's electrical system rather than being plugged into an outlet. These types of water coolers are often used in high-traffic areas or where a more secure connection is desired. The ground fault circuit interrupter, or GFCI, requirements for hardwired EWC may differ from those for plug-in models. Firstly, in some cases, hardwired EWC may not require GFCI protection if they are installed in a location where the risk of water exposure is minimal. For example, if the water cooler is located in a dry equipment room or a dedicated mechanical space, GFCI protection may not be necessary. Secondly, however, many jurisdictions still require GFCI protection for all EWC, regardless of whether they are hardwired or plug-in. This is because the potential for electrical shock still exists, even in dry locations. Thirdly, to determine the specific GFCI requirements for a hardwired EWC, consult the local electrical codes and the manufacturer's instructions. The electrical codes will specify the locations where GFCI protection is required, while the manufacturer's instructions may provide additional guidance and proper installation and grounding of the water cooler. Fourthly, when installing a hardwired EWC, it is important to follow all applicable electrical codes and safety precautions. This includes using properly sized wiring, grounding the water cooler according to the manufacturer's instructions, and ensuring that all connections are tight and secure. Fifthly, if GFCI protection is required for a hardwired EWC, it can be provided by installing a GFCI circuit breaker in the electrical panel. The GFCI circuit breaker will protect the entire circuit, including the water cooler. Alternatively, a GFCI outlet can be installed at the location of the water cooler. Sixthly, it is important to test the GFCI protection after the installation is complete to ensure that it is working properly. This can be done by pressing the test button on the GFCI circuit breaker or outlet. The GFCI should trip, cutting off the power to the water cooler. Seventhly, if you are not comfortable working with electricity, it is best to hire a qualified electrician to install the hardwired EWC and ensure that it meets all applicable codes and safety requirements. A dedicated area or equipment room for electric water coolers, or UCs, is a space specifically designed and designated for the installation and operation of these appliances. These areas are typically separate from general office or public spaces and may offer certain advantages in terms of safety and maintenance. Firstly, one of the main benefits of a dedicated area or equipment room is that it can help minimize the risk of water damage. By locating the EWC in a space away from sensitive equipment or materials, any leaks or spills can be contained more easily, preventing damage to other areas of the building. Secondly, dedicated areas can also provide better control over the environment in which the EWC operates. This can help to maintain the water cooler's efficiency and prolong its lifespan. For example, the area can be kept at a consistent temperature and humidity level, which can prevent condensation and corrosion. Thirdly, in some cases, EWC installed in dedicated areas or equipment rooms may be exempt from certain ground fault circuit interrupter or GFCI requirements. This is because the risk of water exposure is typically lower in these areas. However, it is important to consult the local electrical codes and the manufacturer's instructions to determine the specific GFCI requirements for the installation. Fourthly, even if GFCI protection is not required by code, it may still be a good idea to install it as an added safety measure. GFCI protection can help prevent electrical shock in the event of a ground fault, even in dry locations. Fifthly, when designing a dedicated area or equipment room for EWC, it is important to consider the following factors: adequate ventilation, proper drainage, sufficient lighting, easy access for maintenance and repairs, and compliance with all applicable codes and regulations. Sixthly, in addition to the EWC itself, the dedicated area may also house other equipment such as water filters, storage tanks, and control panels. It is important to ensure that all of this equipment is properly installed and maintained. Seventhly, Regularly inspect the dedicated area or equipment room to check for leaks, spills, and other potential problems. Address any issues promptly to prevent further damage or safety hazards. A qualified electrician plays a crucial role in ensuring the safe and compliant installation of electric water coolers, or UCs, in commercial buildings. Their expertise and knowledge of electrical codes and safety standards are essential for protecting building occupants from potential electrical hazards. Firstly, before installing an EWC, a qualified electrician can assess the electrical system to determine if it is adequate to handle the additional load. They can check the capacity of the circuit breaker, the size of the wiring, and the grounding system to ensure that they meet the requirements of the water cooler. Secondly, the electrician can also determine the appropriate ground fault circuit interrupter, or GFCI, protection for the EWC. They will consider the location of the water cooler, the type of installation, and the local electrical codes to determine if GFCI protection is required and, if so, what type of GFCI device should be used. Thirdly, during the installation process, the electrician will ensure that the EWC is properly grounded according to the manufacturer's instructions and the electrical codes. Proper grounding is essential for preventing electrical shock in the event of a ground fault. Fourthly, the electrician will also make sure that all wiring connections are tight and secure, and that the EWC is properly connected to the electrical system. Loose or faulty connections can create a fire hazard or cause the water cooler to malfunction. Fifthly, after the installation is complete, the electrician will test the EWC to ensure that it is working properly and that the GFCI protection is functioning correctly. They will also provide the building owner or manager with instructions on how to operate and maintain the water cooler safely. Sixthly, in addition to installing new EWC, a qualified electrician can also inspect and repair existing water coolers. They can identify and fix any electrical problems, such as faulty wiring, damaged components, or malfunctioning GFCI devices. Seventhly, it is important to hire a licensed and insured electrician for all electrical work. A licensed electrician has the training and experience necessary to perform electrical work safely and in compliance with the codes. Insurance protects the building owner from liability in case of an accident or injury. Staying up to date with the latest electrical codes and standards is crucial for ensuring the safety and compliance of electrical installations, including those for electric water coolers, or UCs. Electrical codes are constantly evolving to address new technologies, emerging safety concerns, and changing industry practices. Firstly, the National Electrical Code, or NEC, is the primary standard for electrical installations in the United States. It is updated every 3 years by the National Fire Protection Association, or NFPA. Secondly, local jurisdictions often adopt and modify the NEC to suit their specific needs and priorities. It is important to be aware of the local electrical codes in your area and to comply with them. Thirdly, in addition to the NEC, there are other standards that may be relevant to EWC installations, such as those published by Underwriters Laboratories, or AL, the American National Standards Institute, or ANSI, and the Institute of Electrical and Electronics Engineers, or IEE. Fourthly, staying up to date with the latest codes and standards can be challenging, but there are several resources available to help. Firstly, attend training courses and seminars offered by industry organizations and educational institutions. Secondly, subscribe to industry publications and online resources that provide updates on code changes and best practices. Thirdly, join professional organizations that offer networking opportunities and access to technical expertise. Fourthly, consult with qualified electricians and electrical inspectors who are knowledgeable about the latest codes and standards. Fifthly, when electrical codes are updated, it is important to review the changes carefully and to understand how they may affect EWC installations. This may involve updating wiring methods, grounding techniques, or GFCI protection requirements. Sixthly, it is also important to ensure that all electrical equipment used in EWC installations is listed or certified by a recognized testing laboratory, such as UL or ETL. This indicates that the equipment has been tested and meets established safety standards. Seventhly, by staying informed about the latest electrical codes and standards, you can help ensure that EWC installations are safe, compliant, and reliable. This will protect building occupants from electrical hazards and minimize the risk of accidents or injuries. Ultimately, the decision of whether or not to install a ground fault circuit interrupter, or GFCI, for an electric water cooler or UC involves a comprehensive assessment of safety, code compliance, and manufacturer's recommendations. While general guidelines and best practices offer a solid foundation, the specific circumstances of each installation must be carefully considered. Firstly, prioritize safety by evaluating the potential risks associated with water exposure and electrical hazards in the EWC location. If there is a significant risk of water spillage or contact with electrical components, GFCI protection is highly recommended. Secondly, ensure code compliance by consulting local electrical codes and building regulations. These codes may mandate GFCI protection for EWC in certain locations or applications. Ignorance of code requirements is never an excuse for non-compliance. Thirdly, follow manufacturer's instructions meticulously. The EWC manufacturer may specify GFCI protection as a requirement for safe operation or warranty coverage. Failure to comply with manufacturer's instructions could void the warranty or compromise safety. Fourthly, consider the specific characteristics of the EWC itself. Hardwired units or those installed in dedicated areas may have different GFCI requirements compared to plug-in models in general public spaces. Fifthly, err on the side of caution. When in doubt, it is always best to install GFCI protection as an added safety measure. The cost of a GFCI device is minimal compared to the potential consequences of an electrical shock injury. Sixthly, document the decision-making process. Keep records of the code requirements, manufacturer's instructions, and risk assessment that inform the decision to install or not install GFCI protection. This documentation can be valuable in the event of an inspection or liability claim. Seventhly, consult with qualified professionals. Electrical engineers, certified electricians, and building inspectors can provide expert guidance on GFCI requirements and ensure that the EWC installation meets all applicable standards. Eighthly, remember that safety is an ongoing process. Regularly inspect the EWC and its surrounding area for any signs of water leaks, electrical damage, or other hazards. Address any issues promptly to maintain a safe environment.